Tangent. Come on now, we got 2.5 months before the Regents. Where we've seen that word before, tangent. SOHCAHTOA, opposite over adjacent. Yep, we've seen that. Totally unrelated though. Okay, totally unrelated. Here's what a tangent is, as far as we're talking about a circle. Tangent, one line that intersects the circle, one spot only. Okay? A line that can only intersect the circle, one spot only. So look at my diagram there to the left. I drew in 3 tangents for you. Everyone see what I'm talking about? A line that can only intersect once. And those 3 lines only intersect the circle once. Look at my diagram to the right. I got a couple questions for you. Why wouldn't PQ be considered a tangent? What's wrong with PQ? Why doesn't PQ fit my definition? Fits how many times? Twice, right? That's a word coming up later on in the week. Why doesn't TU work? Hits once. What's your problem? Right? It hits once. What's the issue? Not a line. And if I made it into a line, how many times would it intersect? Twice. All right. What's the problem with WV? That intersects once. What's the problem? Again, not a line. If I make it into a line, it's going to hit twice. And then poor RS there doesn't even intersect once. So everyone good. Tangent intersects exactly once. Now, mathematicians are pretty clever back in the day. The point where they intersect the circle, we call the point of tangency. Point of tangency. So in this case, it would be point B, would be called the point of tangency. Why? That's where it intersects the circle. We could also say for point F. I'm not going to keep drawing arrows all the way around, but we could also say the same for point C. Point of tangency, where the tangent hits the circle. All right, you guys are going to learn 2 facts today about a tangent. First one coming up right now. Off to the side for me. You should have enough room off to the side. Draw yourself circle O for me. Go ahead and draw yourself circle O. Draw yourself a tangent line, please. I don't care where it is. Draw yourself a line that's tangent to circle O. Anywhere. A line that's tangent to circle O. And call the point of tangency A. Wherever your circle hits circle, wherever your tangent hits circle O, call that point A. Now I'd like you to draw in a radius. But whoa, here's the condition. The radius has to go to the point of tangency. Has to. I don't want any old radius. I want a radius drawn to the point of tangency. And then everyone is now seeing what you need for our first theorem today. If you have a radius drawn to the point of tangency, guess what happens? The 2 are perpendicular, so they form right angles. All right? But the radius has to be drawn to the point of tangency for it to be perpendicular. If I just have a random chord drawn, not perpendicular. It's a radius only. All right, so all good on the first one. All right, let's use it. Get ready. Numbers getting called out. All right, so for that first one, assume that line's tangent. All right, we can assume that line's tangent. Central angle of 58. What's angle X on the outside? Based on what we just talked about, can you guys add something to my diagram, please? Based on what we just talked about, what can I add to the diagram? 6, what can I add to the diagram? Yep, I can add a right angle right here because this radius is perpendicular to the tangent. And don't overcomplicate it when you find X. I don't need to know anything else about circles to find X. How are we going to find X? Whoa, 3? Yeah, 180 degrees in a good old triangle, minus the 90 we just put in, minus the 58 that was given. And we end up with 32 degrees for X. Okay, but simple. I get it. It's simple. But if you don't know the theorem, it's not. Agreed? We don't know the theorem, we're never doing this problem. All right, how else can we use this theorem? A couple different ways. They tell me AB's tangent to circle C at B, find the value of X. Add something to the diagram before we begin. 4, want to add anything, Griff, what we just talked about?
Right angles.
Yep, where? Can you name the angle?
Angle CBA.
Good job. Angle CBA, radius drawn to the point of tangency. Good work. All right, not using 180 degrees, but something we always use every single unit, it seems. What can I do to find x now? Ho, 17.
You can use Python.
Thank you. Yep. Give me the 2 legs, please. 2 legs, everyone. 2 legs, anybody? Ooh, 3. Eva, back to you. 2 legs. Yep. X squared plus 8 squared. Hey, honors kids, how do I write the hypotenuse there? How do I write that? How do I write how long CA is? 2x, x plus 2. Which one is it? Caitlin? X plus 2. All squared. X squared plus 64. Darn it, you're going to Algebra 2 in 6 months. This is not x squared plus 4. I cannot confidently send you to Algebra 2 if that's what we're going to write. X squared plus 4. Come on, off to the side. X plus 2 times itself. FOIL double distribute. You're better than that. I'll ask somebody what they got in a second. Combine your like terms. All right, you guys multiplied all those through for me. 17 when you're ready. What do we get here?
X.
Get your act together. X squared. You're right here. I'm just asking you, what do you get when we did all this?
Oh.
I don't need a final answer or anything.
Yeah. You get x squared plus 2x. Or wait, plus 4x.
Thank you. Yeah,
Sorry.
You're good. Plus
4. Sorry.
Thank you for making that much more painful than it needed to be.
Sorry.
What's your next move? What's our next move? Got to solve for x, right? Next move. Oh, 21. Subtract the 4. Okay. I'll go with it. X squared plus 60 equals x squared plus 4x. All right, we did that. Next move for anybody here? Oh, 4. Griff, what do you think?
Subtract x squared from both sides.
Yeah, okay. Let's subtract x squared on both sides, and what's going to happen? I don't care which x squared you move over. What's going to happen? See ya! They're gone, aren't they? They cancel each other out. So all I'm left with is 60 equals 4x. I think we could take it from here. Well, 15 spot. Any questions about Pythagorean theorem here? Oh, we're not done with it, though. Oh, we're not done. All right, number 3. Add something to the diagram. Just using our new theorem here today. Add something to our diagram. 16, what do you want to add? Where? Thank you. So now I can do Pythag, but I threw a little trick in here. I only know one leg. X squared. The other leg, BC, is completely blank. So can I even use Pythag? You're darn right I can. What do you know about circles, this unit, that will help me find that other leg? Come on, dig deep. 11?
It's also 3 because it's also radius.
All radii in a circle are congruent. Good, Paul. That radii is 3. All of them are 3. Good work. And it's still not off the hook, you kids. What about the hypotenuse length? Oh, 14. Hypotenuse length. Oh, 21 hypotenuse length. 10. What are we looking at? X squared equals 91. Oh, so sad. I didn't get any rounding directions. Looks like I'll have to make them up on my own. And those rounding directions probably would be what for me? Simplest radical form, yeah. Anybody find a perfect square that goes into 91? I'd love to hear it.
Oh, never mind.
You sure? Go ahead. Throw one out there, John. Throw it out. Well,
I don't think there is any.
I don't think there is one either. Good job. Good job. Square root of 91 is simplified as it gets. Whew. Oh, you kids. All right, hopefully you didn't go too far ahead on 4 because some of you guys may be doing a lot tougher than it needs to be done. Add something to my diagram. 21 again, add something to my diagram. Where? Thank you. So yeah, we'll do Pythag again. I got a suggestion though for everyone. See if you like my suggestion. What are the two legs? What are the two legs? 12. What are my two legs here?
12 and 9.
Good. Where'd the 9 come from?
The radii.
Yep, all congruent. Now, here's my suggestion. Many of you probably would do this. X plus 9, all squared. And then off to the side, you do x plus 9, x plus 9. Would the x squareds cancel out like they did on the last problem? No, I don't have any x squared over here. So what I'm trying to tell you is this problem would end up having to be solved by factoring. Factoring, right? Let me see if you like this a little bit better instead of factoring. Can you guys just find how long this whole hypotenuse is for me? Find how long the whole hypotenuse is, then how could I use that to find x? Subtract 9 from it. Seems a little easier than trying to have to factor. And we know our factoring, is everyone's factoring at an A game of mood? What do you think? You know how to factor. So let's solve for the whole hypotenuse. Just another way of doing it. If you wanted to do x plus 9 times x plus 9, bring everything over and factor. Sure, you're still going to get the same answer. We will. $15. That's the hypotenuse, right? Now we can say x is equal to 15 minus 9, 6. Maybe just a little more convenient than factoring. What are you seeing there, Brendan? Yeah. Cringing right now, everybody. Any questions? Well, that was fact number 1. Radius drawn to a tangent is perpendicular. Next fact, I'm not giving to you. You are going to prove it on your own. Well, not on your own, but together here. Here we go. This is going to be a fun one. Whew. Prove to me BA and BC are congruent. And you know those are tangents as well. All right, let's go. Here we go. I know I say this every time, but we're not going to do this until what? We can't prove BA congruent to BC until triangles are congruent, correct. So we can say CPCTC. All right. You guys are up. How do I get these triangles congruent? Anything you know is true right now. 18, anything you want to throw at me that's true about these two triangles?
Angle A and angle C are right angles.
Okay, let me back up. Claire is 100% correct, but not until step 3. How do you know they're going to be right angles, Claire?
Because A, B, and BC are tangent, and AO and OC are radii.
Yes. Everyone, right? This is the theorem we've been working on today. But here's the thing. Does the theorem say right angles are formed? Does anywhere in the theorem, does it say right angles are formed? Yes or no? No. So that's why I can't write that in step 2, that those are right angles. What I can say, though, in step 2 is AO is perpendicular to the tangent AB. Everyone see, the theorem doesn't say the right angles are formed. It says they're perpendicular. So that's what I'm going to use it for. And then on the other side, I can say OC perpendicular to its tangent, CB. That's what the theorem says. We'll make right angles in a second for you, Claire. All right, here's the theorem. You guys can rewrite it if you want from the first page, but radius drawn. Be careful here of your wording. Where does this radius have to be drawn to? Don't say a tangent, because look, there you go. I just drew it to a tangent. It's got to be drawn specifically to where, Tammy? Point of tangency. Radius drawn to point of tangency is, finish it. I draw a radius to the point of tangency. It is what? Oh boy, 5. Want to finish it? It's got to be perpendicular to something.
The tangent is perpendicular.
So it's perpendicular, is perpendicular to the tangent. A little disappointed there, Greg. You weren't as quick on your feet as you used to be. You're slowing down. Yeah, I get it. It's a long one. Oh well, what are we going to do? Now, ready, Claire? Now I got your right angles. All right, let's see if one of your classmates remembers what to write. Angle A and angle C are right angles. Not by that theorem, but by... Relax. All right, relax. It's showing off. 6! God, karma, Mr. Carlino. Karma! God, I hate that. Go ahead. Lauren? Sure, go ahead.
Perpendicular lines form right angles.
Good. And probably majority of the class has no idea what's going on. Couldn't hear us. That's on me. I deserve that. That's on me. I feel like we've been on this forever already. Anything else you want to tell me about the diagram? Remember, we're trying to get the triangles congruent. 8.
BO is equal to BO because
You all right after that one, Charles? Had to dig deep for that one. It is true, and we do need it, so can't complain. We do need it. You all right, Paul? I think you're thinking in advance. Nope, don't say anything.
No.
No, Paul. We're good. We're good. Trust. We're good. All right, I'm going to save you. We're good. If this comes up 11. Nope, good. 23. What else do we want to say? Nice. AO congruent to OC. I'm going to ask somebody in a second why, so think about it. OA congruent to OC. Ooh, 20? Why?
All radii are
False. All radii are not congruent. In a circle, they are. You see, everyone, you guys always, he's so picky with his wording. This is exactly why. All radii are not congruent. Sorry. All right. But in a circle, they are. Anybody else having the same problem I am? What?
Oh, we haven't set the angles are congruent.
You guys are wanting your right angles congruent so quickly. You can go ahead. You can write that step 6.
Yeah.
But look at my diagram. Okay, even if I do, are those right angles in between the sides? No. So guess what? Side angle side. See you later. Not an option. Have I yet to add side angle? Absolutely not. Absolutely not. You write that on your paper. That'll be the last thing you ever write. All right, because your wrist will be detached. All right, last thing you'll ever write, side angle. It's nothing. I don't care if the right angles are congruent or not. I can't prove these congruent right now. No side angle side, and side angle is not an option. What's up, Avery? What is an option though? HL? Anybody? Oh, don't you do that, Mahmood, all right? You love it. Just admit it. You love it.
Knows what HL is.
Stop! No, oh, they don't.
Hypotenuse leg.
Okay, so you know.
Like, who uses HL, to be honest?
This guy. All right. HL. Well, let's review it again, because obviously nobody knows what it means, because I've never taught it before. H? Hypotenuse. Where is it in the diagram? OB. L? Where is it? AO and OC. What type of triangle do you need to do HL? Do I have a right triangle? Okay, we can do HL. Now, I know some of you guys were real hardcore. Got to prove the angles, right angles congruent. You can, but in an HL proof, you don't need to. Right? It's not needed. But what is needed? You need to say it's a. I don't know. A lot of your classmates kind of remember all this, Mood. Just saying. So yes, I need to tell you the two triangles are right triangles. Triangle AOB and triangle, what's my other one? BOC are right triangles. Right triangles have now they're congruent by HL. And what's going to happen, Moo, in 2.5 months when you're taking the Regents exam and you need HL? You're just going to be like, nah, I'm good. I'm good with this one.
Just gotta hope that there's no HL on the read.
Oh, yeah, you cross your fingers and hope.
Even the state won't use HL. They just,
No.
nobody likes it.
Nobody likes it. Why even teach it anymore, right?
I don't get the point.
And then once the triangles are congruent, which we wanted, now you got your BA and BC congruent. And that'll be true every time now. I get something that looks like this. We just proved those will always be congruent. That's what you just proved. If I have a diagram that looks like this, those two tangents will always be congruent. I just don't need a 8-step proof anymore to prove it. Instead, you'll have a theorem that says the following. First of all, what are A, B, and BC? Those are what? Okay, here we go. Tangents. Here's what you just proved. Tangents drawn to. What's so special about where those two tangents are drawn to? Same point. Good. They're drawn to the same point. Two tangents drawn to the same, and I'm going to add a word in here now. External point. Where does that point have to be? External point. Somewhere outside the circle. Tangents drawn to the same external point are congruent. There's your second theorem. And also, just a little way to remember it, a lot of kids always view it this way. That's not even a grade. That's garbage. If I'm going to do this, I'm going to go all the way. Nope. Still not tangent.
Still not
I'm not listening to a word anybody says. I don't care.
Still not tangent.
So now we know they're equal. Some kids refer to this as the party hat theorem. Party hat, going. Do I need to add them in? Party hat theorem, we're good. Party hat. Okay, there you go. Party. Never ever write that in the reasons column. Party hat theorem. All right, but that's what people think about. All right, so let's actually use this now. Where's this come into play? So now I put a triangle on the outside of the circle, and I want to know what's the perimeter of the triangle. But I didn't give you all three sides. I only gave you one side, 7. So perimeter equals 7 plus the 2 other missing sides, right? All right, how do I find those missing sides? I use my theorem that 2 tangents drawn to the same external point are congruent. Everyone take a look. Everyone see the tangent I've labeled 5? Do you see another tangent that's drawn to the same point as the one that's labeled 5? See these 2 right here? 2 tangents drawn to the same external point are congruent. So I know that one has to be 5. And now I can work my way around the triangle and do the same thing with the 4 up top. If this tangent's 4, the tangent that's also drawn to the same external point is 4. And I can do the same with the 3 and the 3 down here. Everyone seeing the theorem applied 3 times. All right, 3 times that theorem's applied. So now it looks like I have a side of 8 and a side of 9. For a perimeter of 24 centimeters. All right, I know 9. I know 8. Can you guys help me get to the third side so I can find the perimeter? Where do I even start? 2. Matt, where do you want to start here? And remember, these don't cut them in half either. They're not getting bisected. Is there any other tangent you know the length of here, Matt? Any other tangent drawn to the same external point that I can call congruent?
6 and 1 of them.
Good. 6. 6. Right? Those are 2 tangents drawn to the same point. Keep building here. Where can I move from here? 19.
You do 9 minus 6 and get 3 for the other part, and then put the 3 for the other part of the 8. And then
You're done. 9. Where else I gotta go here?
You do 8 minus 3 and you put the 5, and then the 5 is.
And then we finally, good job. And then I finally get 11 for that side. Whew. Whew. Oh boy, quick math, 28 inches. I'm done. Those last 2 are on your own. Anything goes. These last 2. Could be a theorem from today, theorem from 2 days ago. Anything goes. All right, get the job done to find x in both. Find angle x in both 3 and 4. Anything goes. You feel comfortable talking with the people around you, feel free. Anything goes. We've done this unit. Come on. Anything, or this year, for that matter. Anything goes. Think about all the theorems we've done.
Yeah, but I like listening to other
Did you do like 135?
Number 3.
Sorry.
For number 3. What'd you add to your diagram here? Because you need to add something to be able to do it. 9, what do you add to your diagram? Yep, 2 right angles, right? Here and here, because radius drawn to a point of tangency is perpendicular. And then hopefully you guys notice you have 4 sides. How many degrees in every quadrilateral? 360, right? So 360 minus the 290s minus the 130 we gave you. We should have had x equal to 50. Okay, 50. And then this one right here. Ooh. Where'd you go on this one? Oh, 15?
So I said that 50 is, so the radii are congruent.
Okay, good. Making this what type of triangle? Good. So both base angles measure.
50 degrees.
And then from here,
You just subtract this 80 degrees.
yep, minus 100. X equals 80. All right. Let's see if we can sneak one in here before the end.